So back to two proportion tests. We did a two proportion confidence interval. And there's not a whole lot that's different about that than what we've done before. There's some minor changes, but not a whole lot. So now we're going to do hypothesis testings for sample distributions for proportions for two populations. That is a mouthful to say, but most of the time when we do this, not all the time, but most of the time when we do this, the null hypothesis is the proportion from my first sample to my second sample is not any different, or at least not statistically significantly different. Okay? Now, every now and then you'll get one where it's like someone claims that the proportion of this one is 20% higher than the proportion of that. If that's the case, you don't have to do what we're about to do. Okay? But the vast majority are, yeah, the proportion hasn't changed. You know, someone's claiming that the proportion of whatever has changed, and we're dubious. Okay? So we set the null hypothesis as the two proportions are equal to each other and go from there. But that leads us to a problem. So we're assuming that the two proportions are equal. So it doesn't make sense to use the two unequal values, P1 hat and P2 hat, the observed proportion of population 1 and the observed proportion of population 2, right? It doesn't make sense to use that in our standard error, because if we're assuming that those are the same, well, why would we bother? Okay? Instead, what we do is we do what's called pooling. And we do the C in this. I remember when I first read this, I was like, what? Where's the C coming from? It's pooled. It's combined is what the C is for. So you might want to write that someplace. You're combining them. So how many successes did you have in both groups combined, divided by how many people or how many units or whatever did you have in both groups combined?
Can you say that again? Sorry, the X part?
Yeah, that's the number of successes in both groups combined over the number of people or the number of whatever units are in both groups combined.
So then why don't they just use P hat instead of X? If that's like...
Wait, why don't they just use P hat?
Yeah, if it's the success.
There's two different groups.
Yeah, they each have their own P hat.
Yes, but if you're assuming that these are the same, this doesn't make any sense anymore. It doesn't make, because if they're really the same, then all of this stuff starts breaking down, right? We're doing this as if they're two different P1 and P2,
Yeah.
right? Here they're two different things,
Yeah.
but if we assume that the difference is 0, they're equal to each other.
Correct.
We don't, that doesn't make, then you're saying they're different, but now I'm assuming that they're not different.
Okay.
Okay, so the logic doesn't make sense anymore.
Yeah.
If you start with normally we're looking for, all right, the two different groups have two different proportions. Great. Are they 20 points apart? Let's check that. Okay, but if we're assuming that they're equal, we're going to pool them together into one. Okay? All right. And that's what this P hat sub C is, the combined groups, a single pooled proportion. All right, so let's look at this last example. So a survey organization conducted telephone interviews in December of 2008 in which 1,009 randomly selected adults in the United States were asked to respond to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. In December of 2007, so a year earlier, 622 out of 1,020 randomly selected adults in the United States had responded yes to the same question. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to this question changed from December 2007 to December 2008? So we're just asking, is it any different? All right. So let's jump in and start checking. So first thing we have to check when we have two groups is what?
The 2 independent groups.
Pardon?
The 2 independent groups.
It's 2 independent groups. Now, when we're looking for that, we only asked a little over 1,000 each time from all the adults in the United States. Does that seem reasonable then that the 2 groups should be independent? Yes, because we selected a small proportion of all the adults and we did it a year apart. It's unlikely we got the same people twice. Yes, I saw her coming in.
She's doing here.
Stetson's in trouble.
Oh,
Is he
probably.
actually?
No, I'm just.
I'm not present at
Yeah,
all.
would
Like,
they, would they?
All right. So it's reasonable to assume the 2 groups are independent. As we have taken only a small proportion of all adults in the U.S. and taken them a year apart. You can feel it starting to cool down.
Yeah.
yes, good job. Good job, Ed. I'm just kidding.
It was really
She's
awesome.
not it.
All right, so
Yep.
the 2 groups have to be independent of each other. All right? Next.
Random.
Yes? Yeah. So are these random samples?
As stated, yes.
Yes.
Randomly selected.
As stated, each of these samples is random. Or each of these is a random sample. All right, now we need independence within each sample. What rule do we use for that?
It's less than 10% of the total population.
Yeah, so in each sample, the 1,009 and 1,020 adults surveyed is less than 10% of all American adults, or adults in the US. We'll do that. Fewer letters.
Oh my gosh. Miss Stetson, you called it.
Maybe he's not feeling well.
I think he's not. I think he's sick. He slept like went to bed really early last night.
Either that or he just doesn't want to take his geometry test today.
He's
Oh, he has a geometry test
Oh, that's
today?
definitely what it is. I'm just kidding.
I was kidding when I said that.
Oh.
He was right as your brother out.
I'm not kidding.
All right. So, we've got that part. Let's see, what else should we say here?
Success failure condition.
All right, so in each sample, we have more than 10 successes, specifically 676 and 622, and more than 10 failures. And if you want to be, super lazy here, you could do 1009 minus 676 and 1020 minus 622. So have we met all the criteria yet?
Yes.
All right.
Nope.
So the criteria for a 2-sample z-test for proportions have been met.
And
All right.
Did you say we can? I'm sorry. Did you say
Go
we
ahead.
could do 2 samples for means?
We'll talk about that later.
Okay.
We will.
But it'll be on this test.
It will not be on this test. So there's very little about means on this test.
Yeah, it's just the one.
Yeah, it was that one, the very first chapter, we talked about a little bit about means. All right. So my null hypothesis is that P1 is equal to P2.
Is that always what it is?
Not always, but the majority of the time, your null is, nothing has changed.
So the majority of the time, that's P1 is equal to P2.
What would another example be?
So if these had changed, and I noticed a change, and I said, I believe that 10% more people believed that commercials were an effective way to introduce a product in the first year than in the second year. So then I might have, P1 minus P2 is equal to 10.
Okay.
And then I'll test the alternative, is it, greater than?
Oh, okay.
Right, because I've said more than that, not just that it was different. Okay? Now, our alternative hypothesis is going to be what in this case?
Not equal.
It's not equal to.
So you don't have to actually write in the letters, write in the numbers for P1 and P2?
We don't know any numbers for those yet.
Is it not? Oh, it's not P hat. It's not
Right, this is for the population. So we're trying to take a sample and we're trying to infer that to the population. Okay? And we need to explain what P1 and P2 are. It really doesn't matter which is which, because it's just equal to and not equal to. I don't have to keep track of sides on this. That's one of the nice things about this, where P1 is the proportion of adults in the US who would say let's just say, would respond yes to the question. They wrote it that way, I'm going to write it that way.
So we don't have to, we only have to do P1 or P2. We don't have to do both.
We have to do both.
Oh.
I'm not finished with P1. In 2007, and P2 is the same proportion but in 2008. Since my null hypothesis is that P1 is equal to P2, we'll figure out what our, we had it up here, P hat sub C. So P hat sub C is going to be 676 plus 622 over 1,009 plus 1,020. Don't have my stuff out at the moment, so 676 plus 622 divided by 1,009 plus 1,020. I got about 0.64. All right, and then we're gonna go back to this and go, okie dokie. So I'm gonna do my standard error. Is going to be equal to the square root of 0.64 times 0.36 over 1,009 plus 1,020. And I know that doesn't quite look like the way they wrote it. I hate the way that they wrote it. But you can see if you distribute this through that, that's exactly what you have. You've got your pooled times 1 minus your pooled over N1 plus N2. And that, so it's the square root of 0.64 times 0.36 divided by 1,009 plus 1,020. So our standard error is 0.01065, yada, yada, yada. What's the one thing that we didn't do that we probably should have before we got started with this?
Like in the conditions?
No, we did the conditions. I happen to have room right here. Let alpha be equal to, I need to set an alpha level. They didn't specify it. Oh, that doesn't look good.
What? The fact that it's off?
Yeah. Because that's mine. That's the one for this room. All right. So that's our standard error. So let's go ahead and I'm going to grab my calculator, which I have out over here. I'm going to have to move that because that showed everybody's grades. So, all right. So we're doing an inference. We're doing a test. It's a 2 proportion z-test. This one says P1 and P2 is equal to 0 and P1 minus P2 is 0, which is the same thing as saying they're equal, which is what we said. and here it's not equal to 0. Either way you say that is fine. Right, you can say P1 equals P2 or P1 minus P2 is 0. Same thing. All right, so move that down. So I've got 676 out of 1,009. And 622 out of 1,020.
So why do we need to find a standard error? What is that going to tell us?
I'll show you in just a second. So this is what the proportion was in the first instance. So it's almost 67%. In P2, it's down to almost 61%. That's a pretty big drop. We get the pooled proportion. Notice that's the number that I have here. And they give us the z-test statistic. It's 2.822. This is more than 2 standard deviations away from the mean. By the way, if you did it in the other order, it would give you negative that. It would give you a negative instead of a positive.
Negative p-value or negative z?
Negative z. Your p-value can never be negative because it's a probability. You can't have negative probability. So this gives us a p-value of 0.005 approximately. And that should be actually a capital P. And I know it doesn't make much difference, but capital P.
It's a low
Okay.
p-value.
That's pretty low. It's less than 0.05. Therefore, what do?
Reject that.
We reject the null. And there's always an and after that. We reject the null
And believe that they're not equal.
and conclude that what?
The proportion of adults in 2007 or 8, whichever one you want to put first,
It did.
Yeah.
that said yes to the question blank is not equal or has changed. Should I
From
just say
2000.
Yeah.
Say has
So just go up here to this. Do the data provide convincing evidence that,
Start there.
and just copy that. The proportion of adults in the United States. Who would respond yes to the question?
Oh, good.
Hey, what's up?
You have a second to talk.
Yeah, you guys write down the rest.
Do my taxes too while you're at it.
Oh.
Just tell me. Now they're not gonna say it right now.
No, I had it on my desk and JT was like, this is so like mine. He dropped it and he put it in I
know, he does that all the time. No, yeah. Yeah. Cameron, Kinsey, and
So 2 quick things on this. There were 2 things that were working for us on this. Thank you very much. One is that we changed almost 6%, which, given that it was about 60-something% to start with, is a big change. And also, we had big groups,
Yeah.
right? If this had been a small group, we might not have found enough evidence.
Yes.
Right.
True. So what did the standard error mean then?
So the standard error is, so when you're doing, if you were doing a confidence interval, you would use the standard error to help you find what your confidence interval was.
Oh, okay. So then we don't necessarily need the standard error for this one.
Yeah, I'm just showing you what the standard error was on that. So
Okay.
the standard error is pretty small.
Yes.
And so think of that as being like the standard deviation,
Yes.
right? We changed by almost 6%,
That's big.
right?
Yeah.
But we, our standard error is about 1%.
Oh my
Yeah.
gosh.
So we changed a bunch.
Yeah.
Oh my lord.
It's like 6 standard deviations.
Yeah.
So it's a very, very small chance that this could happen.